Hey everyone, it's me, Miss B, and in today's video, we're looking at the Unit 4, Lesson 9 cumulative practice problems for illustrative math geometry. So let's jump in and look at this first question. On question 1 here, we have talking about ramps in a parking garage. So ramps in a parking garage need to be both steep and safe, and the maximum safe incline for a ramp is 8.5 degrees. Is this ramp safe? If not, provide dimensions that would make the ramp safe. So we are going to check these degrees here, and this angle in the bottom left here is what they're talking about. I'm going to label that theta. Since it's an unknown degree measure, theta is traditionally what we would use. So I know using trig functions, sine, cosine, or tangent, we would normally say, because we have 15 as our opposite and 95 as our adjacent, we would normally say that the tangent of theta is 15 over 95. Because remember, SOHCAHTOA, we have sine, opposite, hypotenuse, so ka and toa. So we have opposite and adjacent, so tangent. Now, we want to actually find that theta. So theta right now is currently kind of trapped by that tangent function. Unfortunately for us, there is an inverse of tangent, or you can call it arctangent. I like to call it inverse tangent, so you may hear me just refer to it as that. They mean the same thing, and it's denoted by that tangent with a -1. It appears like a -1 in the exponent. Make that a little clearer. So the inverse tangent, what that does on the left side is just gets rid of tangent and leaves us with theta. And then on the right-hand side, it doesn't have anything to cancel out, so we're just doing inverse tangent, and now of that 15 over 95. And this is what we're able to plug into our calculators. We're going to round it a little bit, but we're trying to make sure this is 8.5 degrees. So that's the maximum, meaning it can be 8.5 or it can be less. So you're going to need a scientific calculator for this. If you don't have one already, you might want to pause and go grab one. And if you don't have one nearby, I would recommend opening maybe in another tab or another device, desmos.com/scientific. So we're going to do the inverse tangent of 15 divided by 95. And oops, this is not a great calculator because I am not using one that apparently has inverses. So I am going to follow my own advice and go find desmos.com/scientific. Okay. So on Desmos, their scientific calculator, you normally have sine, cosine, and tangent. If you need to find the arc cosine, arc sine, arc tangent, there is a little tab. You'll see it says main, and then ABC, and then func. You want to click on func for function, and then underneath sine, cosine, and tangent, it has the inverse versions. So inverse tangent, and this is going to be 15 over 95. And this says, around to 2 degrees after the decimal point, this is 8.97. So that is not allowed because it's bigger than 8.5. So I'm going to say that's greater than 8.5. So we want to be able to make this smaller, a smaller angle. So we want to provide dimensions that would make the ramp safe. So we would say here, I'm just going to say not safe. And we have two ways that we can do that. We can either shorten the height here, which oftentimes is not really what you can do, or we can increase the length. So what I'm going to test on my calculator is if changing this to 100 instead of 95, so 15 over 100, I'm going to check if that comes out to the right thing. That one's a little close. I do see it's 8.53, so it's probably a little too much. Let's bump it up to 105. And yeah, 105 would work. So I would say new dimensions. And I'm just going to draw a little triangle here, but label the pieces. That is not a right angle. That's a right angle, so I can keep this at 15, and I can say this here should be 105. And I can even say that the degrees on this one would be 8.13 degrees. So it works. And that's how I would solve question 1. For question 2, we have ABCD is a rectangle, and we want to find the length of AC and then the measures of alpha and theta. So alpha is the little cursive looking A, that's the Greek letter for A basically, and theta is that circular with the line across it. So we want to find those two angles and then the diagonal of this. Okay, well, we can start with the diagonal because if this is a rectangle, we know that rectangles have right angles. So right angle here in this corner, because it's a rectangle, that means that AC is the hypotenuse. And we can use the Pythagorean theorem to find it. Now, you may also recognize this as a Pythagorean triple. So if you don't trust me and you want to do the Pythagorean theorem, you can, but I'm going to tell you that this one is, oh, actually, it's not a Pythagorean a triple. I was thinking that 3 was a 5, and I was like, yeah, this is 5, 12, and 13. This is absolutely not. So yeah, let's do the Pythagorean theorem. And then I'll try to leave space for my other two angles here. So I'll just do the Pythagorean theorem on this side. So we'll do 3 squared plus 12 squared equals, I'll just call the hypotenuse x squared. So this is 9 plus 144 equals x squared. So my x squared is going to be 153. Now I'm going to actually do the square root of 153 so that we can find a decent number here. So we can say x is square root of 153 just to show what I'm doing, and then that is approximately equal to 12.37. Okay, just in case they wanted it in either format, no, I have both. So that is one piece here. On my rectangle here, it kind of cuts it off. Make sure it doesn't cut it off. Here we go. Okay, so now I want to find theta and alpha. So theta, this one right here. We'll do theta's work, I guess, in blue. And so for theta, 3 is going to be the opposite, and 12 is going to be the adjacent. So with opposite and adjacent, we need to use tangent. So actually, I want to move this a little bit because I was trying to save myself some space, but I didn't want to write too close over there. Okay, so we're going to do this work in blue. So we would normally say that the tangent of theta is our opposite over adjacent. So in this case, that is 3 over 12. Can we reduce that? Yes, we can reduce it to 1/4. You can also still just leave it as 3 over 12. Your calculator will be perfectly capable of doing that. Now we're going to apply inverse tangent to both sides. That means on the left, only thing going to be there is theta. But on the right, we'd have inverse tangent or arc tangent of 3 over 12. I have a hard time calling it arc tangent. I'm just very used to calling it inverse tangent. That's just how I refer to it. So, okay, now this part we're going to plug into a calculator. So, inverse tangent. Oh, that's regular tangent. Inverse tangent of 3 over 12. And calculator says that this is, or a value of theta, is approximately 14.04. If you want to round that to just the whole number 14, that's absolutely fine. I'm probably just going to round to 14, and I'll say it's 14 degrees. Because it's almost exact. It's 14.0 if we were to round to one digit after the decimal point. So you can actually even show that it's like 0.0, but I'm not going to. And then the last piece, technically, I do not even need to use sine, cosine, or tangent, or their inverses, to find alpha. Because alpha here, I'm always bad at drawing it. It's like alpha is equal to 90 minus theta. Because if we added theta to both sides, theta plus alpha equals 90. So we could just subtract from 90. And if you subtract 90 from, if you subtract 14 from 90, so you would get 76. But I'm still going to show the work here. So we would say tangent of alpha. I'm so bad at drawing this one. Tangent of alpha is equal to, now the opposite and adjacent are going to change. So that means that this now is going to be opposite and this one's going to be adjacent. So that means we're going to have 12 over 3. So we would do the inverse tangent to both sides, and we would have alpha is equal to inverse tan of 12 over 3. So alpha equals, and just to check, I'm going to still type that whole thing in the calculator, inverse tangent of 12 over 3. And you could just put 4, because 12 divided by 3 is 4. But this gives us 75.96, so I'm going to round it up and say that it's 76 degrees. So while yes, you can subtract from 90, you can also do it with, you can do this with the trig functions as well, and it works out too. So I like to show all three of them because you may start with alpha instead of theta, and then, you know, I want you to see what that work should look like if you started there. But please do not feel obligated to show the work for every single piece. Through the trig functions, you are able to just subtract from 90. All right, so that brings us to question 3. You want to find the missing measurements. So that is both angles. There's both angles and side lengths. So I have 35 and 21. And then we are going to find our missing side length first. So maybe I'll call this H because it's the hypotenuse. So I would have 35 squared plus 21 squared equals H squared. So 35 squared is a big number, 1,225. Add that to 21 squared. 21 times 21 is 441. I like to switch it around at this point so that I have h squared on the left, and then I'm just adding those two pieces together. So 441 plus 1,225 is going to give me 1,666. Then we're going to take the square root of both sides. That's actually the next step. So I try to show the next step in a different color if I can. And this is going to leave us with h is equal to 1,666. I'm going to round this. I don't think, yeah, I'm just going to leave this in decimal form. This is going to be 40.82. you would get 40.81666326. 40.82 is going to be good enough. So that's our H for hypotenuse. Now we want to find our missing angles. I don't like that it's not a whole number. So in order to find our missing angles, I am only going to use the 35 here and the 21 down below. I'm not going to use H because it's a decimal, and if I use a rounded decimal in some of my calculations, then my calculations may be off a bit. Okay, so that being said, let's start with angle B. So I'll do this one in blue, and I'll just call angle B theta, and we'll say that B has, in this case now, the opposite and the adjacent. So we can say that the opposite and adjacent means we're going to use tangent. So tangent of theta is going to equal to 35 over 21 because tangent is opposite over adjacent. So with my handy dandy calculator, we are going to do the inverse tangent of both sides. So that will cancel out tangent here and just leave us with theta, and then we'll have inverse tangent of 35 over 21. And yes, you can reduce the 35 over 21, but like I said with an earlier problem, you don't have to, and your calculator will still know how to do it. So inverse tangent and 35 over 21, close my parentheses, and this tells me that theta, and because this is so close to a whole number, I'm going to round it to a whole number. This says 59.036, so I'm going to say this is 59 degrees. And that's going to be that angle. Now, we also need to find the other missing angle, which means we can do this with 90 minus 59. So if I said that beta, because I can write beta better than I can write alpha, beta is going to be equal to 90 minus theta. That means that beta is 90 minus 59. So the angle for beta should be 31. And I'm just checking myself here on that because sometimes I am off in the other direction when things are off by like 1 or something like that. But it is 31, so 31 degrees. But because you might have started with angle C, I'm going to actually show that work over here too, the same way I did for the one above. So for C, which is the angle measure is beta, this one here is the opposite. So the 21 is the opposite, and then over on the left is going to be the adjacent. We're still going to use tangent, so I would say that tangent of beta is going to be 21 over 35. We're still going to do inverse tangent of both sides. That's going to remove the regular tangent here on the left and leave us with beta equal to inverse tangent, 21, 35. And when we plug that in a calculator, we should get 31, but I'm going to verify 21 over 35. And yeah, you get 30.96. So we would round that up to 31 degrees because it is so close to that whole number. So I'm going to put a box around this one here. That way, we have all of our answers here from the sine, cosine, tangent, or their inverses here. And but you can always do the 90 minus method to find your opposite one. Like I said on the previous question, I just like to show all three using the trig functions and their equations because I don't know where you might have started with this, especially if you tried your homework before opening up the homework video. So that brings us to question 4. This is from our previous lesson where we learned about sine and cosine kind of being swapped. But really it's just select all true equations. So here we're going to analyze and see which ones are true. So for sine of 27, I'm just going to write out for myself here. So Toa as a reminder. Okay, so sine of 27. So that's putting us here. So that's opposite hypotenuse. Opposite hypotenuse, is that y over 15? Well, on the option they gave me here, they say x over 15, so it's not true. Let's look at cosine of 63. So if we're looking at 63, cosine is adjacent and hypotenuse. Adjacent means next to, and hypotenuse is across from the 90, so that's y over 15. B is a correct answer, y over 15. Okay, now we're doing tangent, so tangent of 27. So again, starting here, tangent is opposite over adjacent, so this should be y over x. And indeed, they do have here y over x, so tangent of 27 should be y over x. C is a correct answer. Now let's look at our sine of 63, remembering sine is opposite hypotenuse, so opposite and hypotenuse, sine of 63 should be x and 15, x over 15, and that's what they have, so D is also correct. And the very last one, tangent of 63, so tangent of 63, the opposite is going to be here, and the adjacent is here, so tangent of 63 should be x over y, and they have y over x, so this one is not true, and your answers are just B, C, and D. That's going to bring us to the back side of the page here, so we'll move on to here. They want to know what value of theta makes this equation true. And so we know that the complementary angles would have their sine and cosine values be the same. So since we have sine and cosine here, sine and cosine, we know that these two need to add up to 90 or need to be complementary. So is it negative 30? Nope. Is it positive 30? Nope. Is it 60? Yes. 60 plus 30 makes 90, and it's definitely not 180. That's just in there as a distractor. So that's question 5. And that is because 60 plus 30 equals 90. And we had sine and cosine swapped. So if I had to show my rationalization or my reasoning here, that's how I would show it, I guess. Okay, so then we're on to number 6 and 7 and 8, and then we're done. So, and this one looks like it is multiple choice. So love it when it's multiple choice instead of parts A, B, C, and D. A rope with a length of 3.5 meters is tied to a stake in the ground to the top of a tent, and it forms a 17-degree angle with the ground. How tall is the tent? So the hint is draw a picture and label it. I will absolutely do that. So even if they didn't tell me to draw a picture and label it, I was going to. So if I make a line like this, I can make a flat line like this and draw a line straight down like that. I'm going to erase some of my ends here. There we go. Cool. This is going to be my rope of 3.5 meters. So maybe like this is the stake it's tied to, like in the ground. I don't know, normally it's like a nail. And like this is the tent or something like that. You can imagine there's like a tent here. It's got like a little, yeah, I don't know. That's a very, very janky version of a tent. But I didn't want to draw it inside the side of the triangle, so you can just imagine that's my tent. So that means they said the rope forms that angle with the ground, so that's 17 degrees. This is going to be 17 right here for 17 degrees. And they want to know how tall is the tent, and they gave us that this was 3.5 meters. So with our right angle here, we're going to do some calculations, and I'm just going to ignore what my options are for right now and just do this question. Based on what I have, x is my opposite from 17 because it's a cross, and then this one here is the hypotenuse. So opposite and hypotenuse would be sine, or the so part from SOHCAHTOA. So I would say sine of that 17 degrees should give me opposite over hypotenuse, so x over 3.5. In order to solve this, I would multiply both sides by 3.5. And I believe their question here is just which equation would allow you to solve for x. So after I write this out, I'm going to look back over at our options and see what they give us, because they don't actually have it rounded, I don't think. This is just going to be 3.5 times sine of 17. So let's go look at what those options are now. Yep. If I found this as my exact height, then 3.5 sine of 17, that is choice. Ooh, set my palm down on here and it started moving it. That is C. All right. Now the next one, they have an angle drawn. They have the angles drawn for us and the triangle, but they're not telling us it's a right triangle, but they want us to find the value of x. They're not telling us it's a right triangle, but I know that 40 and 50 make 90. So that means that this angle right here has to be 90 degrees if my triangle is supposed to add up to 180. Now I can use what I know about sine, cosine, and tangents, and either 40 or 50 to find x. So I'm going to start with a 40 because it's just on the left. So we'll use 40. I'll highlight it so you guys can see, like, that's the one I'm using. Or for anyone looking at this later, or me looking at it later in class. So let's see. That makes x the, oh, nope, not the adjacent. Miss B, what are you doing? That's across from the 90, so this is the hypotenuse. I almost fell into that trap. That makes 3 the adjacent. Okay, but with adjacent and hypotenuse here, if I'm using 40 degrees, I'm going to use cosine. You can still do this question if you use the 50 degrees. It's just now that this is going to be the opposite, and so you would do the sine of 50 degrees and use 3 and x. So I'm going to say that the cosine of 40 is equal to, and that's adjacent over hypotenuse, so 3 over x. Based on the way we would do the math here, we're going to multiply both sides by x and then divide both sides by cosine of 40. You'll end up with the x and the cosine 40 trading places, but I will show all of that work just so that you trust me on it. Those cancel out. We have x times cosine 40, and to get x by itself, we would have to divide both sides now by cosine 40. So x itself, because those would cancel, is going to be equal to 3 divided by cosine of 40. Now, if someone wanted an exact measurement, that is as exact as we're going to get. Stumbling over my words here. So I will give a decimal approximation of this, though, because I'm going to type that in. 3 divided by cosine of 40 degrees. And calculator says that x is 3.916. So you can also just say like 3.9 would be a good estimate for it as well. So I'm going to put some boxes around these because these would technically both be answers for the value of x. Very last one is find the missing side in each triangle using any method and then check your answers. First thing I see here is that I have 2 congruent angles and I have 2 90-degree angles. So I know these are going to be congruent to each other. Not congruent to each other, similar to each other, because they have angle-angle similarity. I'm going to use what I know about similar triangles instead of like Pythagorean theorem, even though I could. Actually, they said any method. This one here, this is a Pythagorean triple. And that is going to be 3, 4, and 5. So I know that x should be equal to 4. And then, you know what? They're going to be similar. So this other one has to be a 3, 4, 5 as well, but it's going to be under a scale factor. So my scale factor here looks like I am multiplying by 3. And if I check, yep, 4 times 3 also makes 12. That means we can do 5 times 3 to get y, and this would be 15. So we're going to say x equals 4 and y equals 15. Now you have multiple ways you could do this. This is the way that I think is the easiest, so that's what I'm giving you. Otherwise, you could use a 3 and 9, realize that there's a scale factor, and then work backwards on all of that. But yeah, so thank you for joining me, and this has been the Unit 4, Lesson 9, Cumulative Practice Problems for Illustrative Math Geometry.